name, firstly, I would like to introduce myself. My name is Muhammad Sefriza bin Hassan. Okay, I'm a postgrad student doing master at Radio Cosmology Research Laboratory, Physics Department in Sitibaya. So today I would like to present my talk about the history of dark matter. Okay, first I would like to point out several questions relating to dark matter and subject of dark matter. Okay, first, how did we discover dark matter, and then what is the research behind that, and then who discovered dark matter, who is the pioneer, okay, and what is the history behind all of this dark matter, and also why is it important to study, to research about the dark matter. Okay, what is the factor affecting us? So, okay, next, this is pie chart of the composition of the universe. It has already mentioned by Dr. Zamri before. Okay, just I want to point out here is the small fractions there. It consists of 0.3 is neutrinos and heavy elements and also stars. Okay, this small percentage, 4%, is a free hydrogen and helium, and then the rest is dark energy and dark matter. Dark matter is consists of 25% and also 70% is dark energy. Okay, so from the pie chart just now, okay, we can see that most of the most of the stuff in our universe is invisible. That is, we cannot feel it, touch it, or smell it. Okay, so so from the pie chart just now, luminous matter is actually in the minority. That is stars, dust, and clouds. And also the gravitating mass and the luminous mass also is the central story of this research on dark matter. It's very related to each other. So for the astronomy before, okay, it may begin as a quest for light, but for astronomy today, it is quest for darkness. So we are seeking for the invisible stuff that we cannot see it with our naked eyes. Okay, this is the summary, so kind of like we can see summary for the dark matter timeline. Okay, starting from the model of galaxy proposed by one of the scientists, Jacobus Cornelius Kapteyn. Okay, what is he is proposed is the galaxy. Our galaxy is some kind like an immense elliptical congregation of stars. Okay, with our solar system is near to the center of the galaxy. Okay, so after 20 years, about 20 years later, okay, this kind of model is widely accepted for many astronomers. Okay, so further observation is carried out by a lot of astronomers or astrophysicists, such as Vesto Melvin Slipher, and also later by Edwin Hubble, study on the observation similar to the spectral line observation. That is, we can call it as a spectroscopy. So by far, most of the galaxies studied show a redshift. That is, the galaxy is moving away from our own Milky Way. And also, okay, so by far, we know that our universe is expanding. So the galaxy is actually receding about each other. So, and then also emerged one of the scientists named Hern van der Haas, okay, predicted the emission of 21 centimeter spectral line of neutral hydrogen at the Leiden Observatory, Netherlands, by using 7.5 meter radio telescopes. Actually, not radio telescope, actually it is a radio radar, and then converted into radio telescope for the observations. And also within 25 until 30, okay, 3 scientists emerged, okay, involved in the discovery of the galaxy's rotation and also dynamics of the galaxy. Okay, in 1932, Jan Wood, okay, study the detail about the amount of matter in the disk of the galaxy, and also next year, in 1933, Fritz Zwicky, okay, is the first person theorized the existence of the dark matter. Okay, and also within 40 until 50s, Wood continued his study and research also in the dark matter consisting in the disk of the galaxy. Okay, in 1957, okay, high H1 rotation curve M31 is also obtained by Van der Haas. Okay, I will show you the image. Okay, this is the image for M31 Andromeda galaxy. Okay, we can see the variation of the velocity of the stars in this galaxy M31. So what I want to point here is this is the optical image. Okay, the range of the optical image is from here until here. So by using radio astronomy, okay, we can extend our scopes to more distant from the galactic center. So this is the results obtained by Robert and Haas in 1975. So we can see the extension of the hydrogen line spectra. Okay, continue. Okay, in 1970, Vera Rubin and Ken Ford also study on the M31 Andromeda galaxy for a flat optical rotation curve. Okay, and then after 3 years later, two scientists conclude that there is halos of the galaxy that stabilize the galactic disk. Okay, next 74, okay, 3 of the scientists, okay, summarize that the evidence that M/L, that is mass to light ratio, is increases with radius. Okay, this is the one of the scientists, Vera Rubin, and this one is Wood. Okay, so this dark matter also extend for this study of dark matter is also extend for galaxy cluster, not only in galaxy. And then also in 1980, most of the astronomers around the world, we can see that, convinced that dark matter exists in galaxy and also in galaxy cluster as well. Okay, this is the structure of the Milky Way, our own Milky Way. This is the disk, okay, bulge. Okay, this is the halo. Okay, just like a lamp. Okay, lamp sometimes like dia ada macam kelubung. Okay, bahasa Melayunya. Okay, just like that. Okay, I want to point out one of the the most important pioneer in dark matter study, that is Fritz Zwicky. He studied on the coma cluster, and then he is the first person who theorized the dark matter theory at 1933 that I mentioned just now. Okay, after he observed that there is 400 times masses in the coma cluster, compare there should be, and had expected there to be. So there must be something, okay, that couldn't be seen accounted for the rest of this mass. So by studying a group of galaxies, okay, 10 million light years away from one another, he observed that their relative speed were much too great, okay, for them to hold by the gravitational attraction of the visible mass alone. So he also predicted that how dark matter is in the universe is mapped. It can be mapped, okay, using the gravitational lensing, and also based on the general relativity, Einstein general relativity. So this is the guy, okay, the scientist, Fritz Zwicky. Okay, so why is exactly important in searching for dark matter? Actually, there is 3 different theories about the structure or shape of the universe in the question just now. Okay, there is open, closed and flat. Okay, the first theory is open, state that the universe will expand forever, so there is no ending for that. Okay, and the second is closed. Okay, at a certain time the universe will stop expanding and recollapse into itself. Okay, and the third one is flat. It will expand forever, but the expansion rate is just, going to be slow to zero at infinite time. So we are not know when this time will come. Okay, and also the study of the dark matter explain a lot of the characteristic of the universe, and then the composition of the universe also. Of today, its past, and also its evolution and its future of fate. Okay, and then the study of the dark matter also tell us the information about the shape of the universe. Okay, there is 2 types of dark matter. There is HDM, there is hot dark matter, and also CDM, cold dark matter. Okay, this is the timeline, the historical journey of the type of the dark matter. Okay, begin is in 1970s until 1980s. Okay, HDM, hot dark matter, is look like the best candidate. Okay, and then also for a few years, a new model called CDM describe most successful structure formation model compared to HDM. Okay, so there is the timeline of the CDM, and until in 2003 there is a new structure, lambda CDM. Okay, the CDM being possibly WIMPs and axions, okay, appear to fit the large scale structure observation well. Okay, and then until now they will still study about the lambda CDM. Okay, so WIMPs and machos. Okay, what is this? Okay, this is 2 most popular candidates for dark matter. Okay, WIMPs is acronym for weakly interacting massive particles. Okay, interacts through force and gravity. Okay, they cannot be seen directly. Okay, and also they do not interact with the strong nuclear force. Okay, for example, is neutrinos and also neutralinos. Okay, the second candidate is machos. Okay, there is acronym for massive astrophysical compact halo object. Okay, composed of normal baryonic matter. Okay, would be very hard to detect because this kind of particles do not emit any light. Okay, for example, black holes and also neutron stars. Okay, thank you.